Hey everyone, today we are going to solve the Daily LeetCode challenge of 24th March 2024, and the problem statement is find the duplicate number. So let us first understand the problem statement. So according to the problem statement, we have been given an integer array num such that it contains integers in the range of 1 to n. Okay, and both these 1 and n are inclusive. That is, we are going to include the integer 1 and n as well. So here we can see that in this nums, what is the range? The range is from 1 to 6, correct? And what we have to do is we have to find the duplicate number. What does it mean? It means that in this nums, there exists an integer which is repeating itself, and it can repeat itself 2 or more than 2 times. Okay, so we have to find that repeating number. So let's see how we can solve this. So what we can do is we can make use of a frequency array which will have a size same as that of nums. So here we can see that nums is having a size of 7. So it will create a frequency array of size 7. And what we will do is we will initialize all the values as 0. Okay. And what will this frequency array do is this frequency array will keep track of the frequency of all the elements present in this nums. Correct. So what we will do is we will iterate over nums to populate this frequency array, Okay. So currently we are at this 1. So what we'll do, we will increment the frequency of 1. Okay. Then we'll move this pointer. Now we are at 3. What we'll do, we'll increment the frequency of 3. Now we'll move forward. We are at 5. We'll increment the frequency of 5. We'll move forward. We are at 4. We'll increment the frequency of 4 and we'll move forward again. So we are at 2. What we'll do, we'll increment its frequency to 1. Again, we'll move forward. Now we are again at 2. So what we'll do, we will increment its frequency. Now we can see that this 2 is having a frequency of 2. So what does it mean? It means that it's the repeating number. So what we can do is while populating this frequency array, we'll add a check that if frequency of any element, let this represent the current element. Okay, so if the frequency of any element is greater than equal to 2, in that case, what we'll do, we'll simply return that element. Correct. So here we can see that what is the frequency of 2? We have got the frequency of 2 as 2, correct? Which is greater than equal to 2. So what we'll do, we'll simply return this 2, indicating that this is the duplicate number. Okay. So what would be the time complexity for this solution? The time complexity for this solution would be order of n. Why? Because there could be a possibility that the repeating number could be present at the very end of the nums array, correct? So in that case, we'll have to iterate over all the n elements. So therefore, the time complexity is order of n. And what is the space complexity? The space complexity is order of n as well, because we are creating a frequency array that has a size same as that of nums, correct? Let's see if we are going to use this solution or not. So the answer to that is no. Now let's understand why. So we can see that in the problem statement, it's clearly mentioned that we have to use only constant extra space. Okay. And what we are doing over here, in this solution, we are using a space complexity of order of n. So that's the reason we are not going to use this solution in order to solve this problem. So let's see what else we can do. So since we can't use any extra space, so what we can do is you can say that, okay, since we can't use any extra space, what we'll do, we'll simply sort this num. So what we'll do, we'll sort nums. So if we'll sort this nums, what we'll get 1, 2, 2, 3, 4, 5, and a 6 over here. And what we can do is we can take 2 pointers, P1 and P2, and we'll say that we'll move this P1 and P2 until they are not equal. Okay. And if we'll get that this P1 is equals to this P2, that is the value at P1 and the value at P2 are equal, in that case, what we'll do, it means that we have got the duplicate number. So simply we'll return either P1 or P2. So let's return this P1. So let's check whether the value of P1 and P2 are equal. So we can see that P1 is 1 and P2 is 2. So they are not equal. So what we'll do, we'll increment this P1 and we'll increment this P2 as well. Okay. So now we'll check that the value at P1 is 2 and the value at P2 is also 2. And these two values are equal. So what does it mean? It means that we have got the duplicate number, correct? So what we'll do, we'll simply return this P1. So we'll return this 2, indicating that this is the duplicate number. Now, the question is that are we going to use this solution? The answer is again no. Now, let's see why. So here in the problem statement, we can see that it's clearly mentioned that we cannot modify the given array. And what we are doing over here, we are sorting this array, correct? So it means that we are modifying this array. So we have understood 2 points, that we have to solve this problem without modifying this nums and without using any extra space. So let's see how we can solve it by following these 2 conditions. So since we can't use any extra space and we can't modify the array nums, so what we will do is, so we will make use of 2 pointers, slow and fast. Okay. And what we will do is, if you remember the problem linked list cycle 2, then what we used to do in that problem is we used to move the slope pointer by 1 step and we used to move the fast pointer by 2 steps until the slope pointer and fast pointer were not equal. And what we wanted to solve in that problem was we wanted to find the starting point of the cycle, correct? So this problem is similar to that problem. Let's see how. So what we will do is, in this problem, we will consider each of the indices, that is the 0th index, first index, second index, third index, fourth index, fifth index, and sixth index as the nodes. And we will consider these elements, that is this 1, 3, 5, 4, 2, 2, and 6 as the next element, correct? So if we'll consider it like that, so let's see how our linked list will look. Okay. So firstly, we will have this 0th node. After that, what is the next of this 0th node? The next of this 0th node is this one, correct? Because what we are considering value as next, and we are considering index as the node, correct? So our first node is this 0th node, and what is in the next of this 0th node? In the next of this 0th node, we have 1. Okay, so now we have 1. Now what is the next of this one? The next of this one is this 3, correct? So we'll have 3 over here. Now what is the next of this 3? The next of this 3 is the value at it. And what is the value present at it? The value present at it is 4, correct? So after 3, we'll have 4. Now, what is the value present at the fourth index? The value present at fourth index is 2, and it represents the next element to 4. So after 4, we have 2. Now, what would be the next of 2? The next of 2 would be the value present at the second index. And what is it? It's 5. So we'll have 5 over here. Correct. Now what would be the next of this 5? The next of 5 would be the value present at the fifth index. And what is the value present at the fifth index? It's 2. Okay. So it's 2. And what would be the next of this 2? The next of this 2 would be the value present at the second index. And what is the value present at the second index? It's 5. Okay, so we can see that this 5 is coming again. And what is the next of this 5? The next of this 5 is 2. So we can see that we are getting 2, 5, 2, 5, 2, 5 again and again. So what does it mean? It means that after this 5, we have a cycle, correct? So we can see that we have 2, 5. Again, we'll have 2, 5, 2, 5, 2, 5, infinite number of times, correct? So it indicates that we are having a cycle in this linked list. Okay. Now, how we used to find cycle in a linked list? We used to take 2 pointers, slow and fast. And what we used to do is we used to move this slow pointer by 1 step and this fast pointer by 2 steps until they are not equal. And the moment they will become equal, it indicates that it's having a cycle. And when we'll get that it's having a cycle, now what do we want to do? We want to find the starting point of the cycle, correct? In this case, we can see that this 2 is the starting point of this cycle. And the starting point of this cycle will represent what? Starting point of cycle, it represents the duplicate number. Okay. Whenever get the starting point of the cycle, it represents the duplicate number. So it's the duplicate number. So let's see how are we going to solve this problem. So initially what we'll do is, we'll take slow as nums of 0 and we'll take fast as nums of 0, correct? Why? It's because we'll be moving this fast pointer by 2 steps and this slow pointer by 1 step, correct? And what we'll say that while this slow is not equals to this fast pointer, correct? Until that, what are we going to do? Until that, we'll say that move this slow pointer by 1 step. Now, what does moving slow pointer by 1 step means? It means that we'll set slow as the next of slow. And what is the next of slow? The next of slow is nothing but nums of slow, correct? And what we'll do, and we'll move this fast pointer by 2 steps. That is, we'll set fast as nums of fast, correct? Fine. Now let's do a quick dry run over this test case in order to understand this in a better way. So initially, what would be the value of slow? The value of slow would be nums of 0. And what is nums of 0? Nums of 0 is 1. So we will have 1 in slow. And what would be fast? Fast would be nums of 0. Okay. So what is nums of 0? Nums of 0 is 1. And what is nums of 1? So we can see that nums of 1 is 3. Correct? So we will have 3 in fast. So what does it mean? It means that our slow pointer is present here. So we have slow over here. Let me represent it with S. Okay. So slow is over here and fast is over here. And what we have to do, we'll check that while the slow and fast are not equal, we have to do this. So we can clearly see that slow and fast are not equal. So what we'll do, we'll move slow by 1 step. So how are we going to move slow? We are going to set slow as nums of slow. So what would be nums of slow? So we can see that slow is 1. So what would be nums of 1? Nums of 1 is 3. So we will set slow as 3, correct? And we can clearly see that where is slow? Slow will now move to this 3, okay? Indicating that slow has moved by 1 step, correct? Now, what are we going to do with the fast? We are going to move this fast by 2 steps. And how are we going to do that? We are going to do that by setting this fast as nums of fast, correct? What is nums of fast? We have fast as 3. So nums of 3 would be 4. And again, we have to move it by one step. So what would be nums of 4? The nums of 4 would be this 2, correct? So what does it mean? It means that we have 2 in fast. So fast has now reached to this 2, correct? Now again, we'll check. Is this slow and fast equal? So we can clearly see that slow and fast are not equal. So what we'll do, we'll move slow by one step and fast by 2 steps. So what we will set the slow as? We'll set the slow as nums of 3. So what is nums of 3? Nums of 3 is 4, correct? So our slow will now be 4. That is, our slow will move by one step and it will point at this 4, correct? Now what will we do with this fast? We'll move this fast pointer by 2 steps. That is, we'll set this fast as nums of 2, okay? So what is nums of 2? We can clearly see that nums of 2 is 5. And what is nums of 5? Nums of 5 is this 2. So it means that fast will now become 2. So it means that this fast has moved by 2 steps. So this fast, if it moves by one step, it will reach to this 5, and it will move by 2 steps, then it will reach to this 2 again. So it means that this fast has reached to this 2 again, correct? Now what we'll do, we'll again check that is this 4 and 2 equal? So 4 and 2 are not equal. So what we'll do, we'll move the slow pointer by one step. So we will set this slow as nums of 4, correct? What is nums of 4? We can see that nums of 4 is nothing but 2. So we'll set this slow as 2. So it means that the slow pointer have reached over here. And what we'll do with the fast, we'll move fast by 2 steps. So we'll set the fast as nums of 2. Now what is nums of 2? Nums of 2 is 5. Now what is nums of 5? Nums of 5 is 2. So what we'll get in fast, we'll get 2 only. So it means that this fast has moved by one step and it has moved by 2 steps and it has reached the same position, correct? Now what we'll check that is this slow not equal to fast. So we can clearly see that the slow and the fast is equal, correct? Now, the moment they will become equal, what does it mean? It means that cycle exists. And what does cycle exist means in this case? In this case, the meaning of cycle exist means that duplicate number exists, okay? Now, since duplicate number exists, so what do we want to find? We want to find that which is the duplicate number, correct? Now, let's see how are we going to do it. So, whenever we used to solve this problem in case of a linked list, so what we have to do? We wanted to first find whether cycle exists or not. Now, we have got that cycle exists. Now, what did we wanted to find after that? After that, we want to find out that what is the starting point of the cycle, right? Like in this case, what is the starting point of the cycle? The starting point of the cycle is 2, correct? And the starting point of this cycle, what does it represent? The starting point of cycle represent the duplicate number, correct? So how are we going to find out the starting point of this cycle? So for finding out the starting point of the cycle, we are going to reset this fast as 0. And what does this 0 means? It means that we are going to reset the fast pointer at the starting element, that is at the starting node of the linked list, correct? So what is the starting node of the linked list? The starting node of the linked list is 0. So it means that we'll set our fast pointer at this 0. Okay, and slow will remain at its position. And what we'll do, we'll say that while the slow and the fast is not equal, while slow is not equals to fast, what we will do, we will move slow by one step. That is, we'll set slow as nums of slow, correct? And we'll move fast by one step as well. That is, we'll set fast as nums of fast. Fine. And the moment these two will become equal, then what does it mean? It means that we have got the starting point of the cycle. So why were we doing this while loop? We were doing this while loop to check whether cycle exists or not. Okay, cycle exists or not. Now, once we have found out that cycle exists, then what are we going to do? We are going to find the starting point of cycle. Starting point of cycle. So for finding out the starting point of cycle, we are going to run this while loop. And before that, what are we going to do? We are going to set the fast as 0. That is, we are going to set the fast as the first node of the cycle, correct? So let's see how are we going to solve it. So where is our fast pointer? We can clearly see that our fast pointer is at this 0th node, correct? Okay. So what are we going to do? We are going to check that is this 2 and 0 equal? No. So what we'll do, we'll move each of them by one step. So how are we going to move the slow pointer? We'll set the slow pointer as nums of 2. And what is nums of 2? Nums of 2 is 5. So it will be 5. So what does it mean? It means that our slow pointer has reached over here. Okay, fine. Now what are we going to do? We are going to move this fast pointer by one step as well. That is, we are going to set this fast as nums of 0. And what is nums of 0? Nums of 0 is 1. So we'll get a 1 over here. So we can clearly see that this fast pointer has moved from this 0 to this 1th node, correct? Now what we'll do, we'll check that this 5 and this 1 are not equal. So what we'll do, we'll move both of them by one step. So we will set slow as nums of 5. So what is nums of 5? Nums of 5 is 2. So we'll have 2 over here. That is, our slow pointer has reached to this 2, correct? Now we'll move this fast pointer by one step as well. So we'll set this fast as nums of 1. So what is nums of 1? Nums of 1 is 3. So we'll get a 3 over here. Fine. Now again, this 2 and 3 are not equal. So what we'll do, we'll move this slow and fast pointer by one step. So what we'll get, we'll set slow as nums of 2. So what is nums of 2? Nums of 2 is 5. So it means that the slow pointer has reached over here again, correct? And what we'll do, the fast pointer will also move by one step. So we'll set this fast as nums of 3. And what is nums of 3? It's 4, correct? So we'll have 4 over here. So we can clearly see that, okay, our fast pointer was here. So we have moved this fast pointer from this 3 to this 4. Fine. Now what we'll do, we'll again check that this 5 and this 4 are not equal. So what we'll do, we'll move the slow pointer by one step. So what is nums of 5? Nums of 5 is 2. So we'll get a 2 over here. It means that the slow pointer has reached to this 2 again. And we'll move this fast pointer by one step. That is, we'll set this fast as nums of 4. What is nums of 4? Nums of 4 is 2. So we'll get a 2 over here. Okay. Now again, we'll check. Is this slow not equals to fast? So we can see that we have 2 in this slow and we have 2 in this fast. Correct. We can see that our slow pointer is pointing at 2 and our fast pointer is also pointing at 2. It means that slow has become equal to fast. So what does it mean? It means that we have got the starting point of the cycle. And what does the starting point of the cycle indicate? The starting point of the cycle indicate the duplicate number. Correct. So what we will do, we will simply return either slow or we will return fast. So let's return slow. So we'll return slow. So if we'll return slow, what we'll get? We'll get 2, indicating that 2 is the duplicate number. Correct. So now that we have understood this approach, so let's quickly code this. So what we will do is we will take a slow pointer, which would be initially nums of 0. And we'll take a fast pointer, which would be initially nums of 0. Correct. And what we have to do, first we have to check whether cycle exists or not. Cycle exists or not. And what does this mean? This means that we are going to check whether duplicate exists or not. Correct. Let's see what are we going to do. So we will say that while the slow is not equals to fast, then what we have to do, we have to move slow pointer by one step. So what we'll do, we'll set slow as nums of slow. Correct. And after that, what we have to do, we have to move this fast pointer by 2 steps. So we will set fast as nums of fast. Fine. Now, once we will come out of this while loop, what does it mean? It means that this slow has become equal to this fast. So what does it indicate? Indicates that we have got a cycle, that is duplicate exists. So what we have to do is, if we have got that cycle exists, so what we used to do in case of linked list cycle 2, in that case, we used to find the starting point of the cycle, right? And what does the starting point of the cycle represent? The starting point of the cycle represent the duplicate number. Correct. So for that, what we have to do, we have to first set this fast pointer to the first node. And what is the first node of our linked list? The first node was the 0th node. Correct. So we will set this fast to 0. And what we'll do, we'll say that while the slow is not equals to fast, what we have to do is we have to move the slow pointer by one step. That is, we'll set slow as nums of slow. And we have to move this fast pointer by one step. That is, we'll set this fast as nums of fast. Correct. Now the moment this slow and fast will become equal. So what does it mean? It means that we have got the starting point of the cycle. And what does the starting point of the cycle represent? The starting point of the cycle represent the number which is repeating itself. Correct. That is the duplicate number. So what we'll do, we'll simply return slow, or we can also return fast, because both are pointing at the same element, right? But before that, we have to handle one more case, and it's that we can clearly see that what is this n? This n represents the length of our nums. Correct. So the length could be 1 as well. So if the length would be 1, in that case, we are not going to have any duplicate numbers. Correct. So if we'll have a length as 1, so we'll simply say that if nums.size is 1, in that case, what are we going to return? We are going to return -1, indicating that no duplicate element exists. Correct. So now let's quickly run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity. So if we have a total of n nodes present in our linked list, or if we can say that if we have a total of n elements present in our nums, then what would be the time complexity? The time complexity would be order of n. Now let's see how. So what are we doing over here? Here we are iterating over all the elements present in nums in order to find out whether it has a duplicate number or not. Correct. So it's going to cost us a time complexity of order of n. After that, what we are doing over here, we are finding out the starting point of the cycle. That is, here we are trying to find out that which is the number that's repeating itself. Correct. And for that, again, we can have to iterate over all the n elements. So it is again going to cost us a time complexity of order of n. So order of n plus order of n will give us order of 2n. Since 2 is the constant, so we can ignore it. So eventually we will get order of n only. Correct. And we can clearly see that we are not using any extra space from our end. So therefore, the space complexity would be order of 1. So that's all about today's daily LeetCode challenge. Thank you.